Today's topic is carbon and its compound. Now, point is that carbon. Carbon is the element which symbol is the C, atomic number is 6 and atomic weight is 12. And in atmosphere, carbon is available in the atmosphere, it is available in 0.03% only in the form of coal, petroleum and the carbonate form. And in air, in the form of carbon dioxide, it is available in 0.33%, here in atmosphere 0.2%, and in the air it is available in the form of 0.03%. If you count the proportion, so only in fully it was present only the 0.05%, but very little bit proportion it is available. But if you see the proportion, the compound of the carbon, so the uncountable number of compound can be formed with the help of this carbon. And why? This is why, because of the property of the catenation property. Now, what is the catenation property and why this compound can be formed, that we will see in a little bit afterward. We are going to study about that. Now, one thing is that if I'll ask you one question, without carbon we can't survive. So if I'll ask such type of question, you maybe answer me, no ma'am, it cannot be possible. Without carbon, how we can survive? Without carbon we can survive, no? Because we are not eating the coal, we are not eating the petroleum, but we are knowing that carbon is present in each and every, maximum, almost all the component, carbon is present as a very important element. For example, we are eating the carbohydrate, we are eating the protein, we are eating the fat, in that also carbon is present. So the clothes we are wearing, the things we are purchasing, number of things are there where carbon is present, and that's why carbon plays a very important role in our life. If carbon is not there, then with the help of carbon dioxide, plants will not prepare the food, photosynthesis will not occur, and if photosynthesis will not occur, we will not get the food, and that's why we can't survive. And that's why carbon is the most essential element in our life also. It plays a very important role in our life also. Now just we are going to study something detail about this particular carbon. Now this carbon has atomic number 6. 6 means K shell containing. If I will write down here shell wise configuration, then K shell containing 2 electron and L shell containing 4 electron. Okay. Now this particular configuration is called as shell wise configuration. I want to explain here electronic configuration of the carbon shell wise configuration here. Just to see, this is the carbon element. First shell, K shell. This K shell has the capability to accommodate 2 electrons. Then second shell is the L shell. S shell has the capability to accommodate 8 electrons. But here carbon has only 6 electrons. So K shell containing 2 electrons and rest 4 electrons are there in the L shell. Now, according to the electronic configuration, L shell shows the stability when it has totally 8 electrons. Now here totally 4 electrons are there, and that's why this shell is the half filled shell. So according to shell wise configuration, we can write down the shell wise configuration 2 as well as 4. So half filled, and that's why according to this also carbon is half filled, means it has the 4 free valencies, and here it shows the free valencies, 4 free valencies. In our chemistry, 4 means mono, di, tri, tetra, and that's why here 4 valencies are there, and that's why this carbon has the 4 valency, so it is called tetravalence. Carbon is tetravalence, it shows the tetravalency. Now, this is about the shell wise configuration which we are studying. We have completed in 9th standard also and 10th standard also. But in 11th standard and 12th standard, we need to study little bit detail, and that detail is called as the subshell wise configuration. Now, what is that subshell wise configuration? It's one of the very amazing type of world. Just like this is the nucleus, around the nucleus shells are just revolving, just like a sun is revolving around our earth. In the same way, here also the same type of phenomena is shown. So here subshell wise configuration. Now subshell wise configuration purpose, we must recall our knowledge of the periodic table where I have explained you that block element, S block element, P block element, D block element and F block element. That time I have explained you that S block has the capacity to accommodate 2 electron, P block has the capacity to accommodate 6 electron, D block has the capacity to accommodate 10 electron and F block has the capacity to accommodate 14 electron, and that's why we have seen that periodic table divided into 4 parts: S block, P block, D block and the F block. Now here S, P, D, F, these are the subshells. These are the subshells of the particular element. Now subshells. How subshells? S, P, D, F. Now carbon. Carbon has a 6 electron, and that's why now subshells are there. Just to see, this is the 1s subshell which has the capability to accommodate 2 electron, because already S shell has the capacity to accommodate 2 electron. Now second step start, 2s2, okay, 2s2, then 2px1, 2py1, 2pz0. Just to see here, 2 and 2 4, then this is the 5 and this is the 6. Totally, how many steps are there? How many stages are there? First step, and this is the second step. If I am going to denote this thing, so we can denote it like that. This is one box. This contains 2 electron. This box, it has the 3 pair, px orbital, py and pz. Okay. So this is the S block. Which S block? This is the S block, 1s block, this is the 2s block, and this is the p orbital, 1, 2. How many are there in the p orbital? px1, py1, pz0. So this is which block? This is which block? This is the 1s2. This is 2s2. This is 2px1, 2py1, and here 2pz0 is there. Now, just to see, if we want to climb up the staircases, if I am standing on the first step and if I need to climb to the second step, so that time I require little bit energy to just jump from first step to the other second step. But if I am on the ground floor and I need to only walk from one place to another, I didn't require that much energy which I was requiring for the jumping the steps. Here also same pattern will be there. This is the first step and this is the second step. Now here just to see, this block has the capacity to accommodate 2 electrons, so 2 electrons are there. This 2 block has the capacity to accommodate 2 electrons, but here only single electrons are there. And just see this particular last block, this block is empty. While we are traveling in the bus, that time what we are thinking, we want to shift to us towards the window place, nearby the window place. If window place is not vacant, we are just observing if that particular person, traveler, was just getting down, that time we want to shift to that place. The same thing happened here also. Just to see, here 2s2 electrons are there, and here how many electrons are there? 0 electron. So what they are doing, energy level is same. So from 2s2, 1 electron is shifted to the 2pz0, that block. So what will happen? If such a condition will be there, then what will be the condition of the structure will be there? Here exactly 1s2 as it is, 2s2. Now here what will be the condition? Here 1s2 as it is. Now instead of 2, how many are there? Only 1 will be there because 1 has been shifted. Then here also 1, here also 1, here also 1. You can see here the capability now. Now this become 1s2, this become 2s1, 2px1, 2py1, 2pz1. Now here it has the capacity to accommodate 2 electron, 1 is present. Here also each block has the capacity to accommodate 2 electron and 1 electron is there. Means exactly double की capability है, लेकिन valence electrons ऐसे हैं half filled. It is the half filled electrons are there. And now the configuration has been changed. What will be the configuration now? Now configuration will be carbon 6. Configuration will be 1s2 as it is. Then now instead of 2s2, what will be there? 2s1, 2px1, 2py1, 2pz1, and that's why this type of configuration we will get. Now this configuration which will be earlier will be there, actual configuration will be there. This configuration is called as ground state configuration. This is called as ground state configuration, and this configuration which will be after the changing the place, this is called as excited state configuration. Now here I have shown the configuration. This is the excited state configuration. Just have a look. It's a very magical, very beautiful type of structure will be there. Carbon. Carbon has, this is the first shell. First shell 1s2. Just to see 1s2 first shell. It has how many electrons? 2 electrons. So these are the 2 electron 1s2. Now how many are there? 2s1. Just to see, this will be this pink color block, the circle is the 2s1 electron. Okay. Now S orbitals are the circular one and the P orbitals are the dumbbell shape. We have already studied the S orbital, structure of S orbital, P orbital and the D orbital. In our another video, we will study in detail. So S orbital, so here also S means circular in shape, spherical in shape. Now just to see 2px1. So this is the layer of 2px1. So this is the 2px electron. Then next one 2py1. This is the 2py electron. And lastly, this will be 2pz electron. So in this way, dumbbell shape, these 3p electrons are the dumbbell shape electron. And you can imagine only 6 electrons are there, then also structure is so beautiful. This whichever number, whenever number will be increased, the structure is also increased. And now here, actually what is happening, the electron has been shifted from S1 orbital to 2pz orbital, and that's why it was not requiring the energy. Why? Because it is on the same floor, same shell, and that's why this configuration is called as excited state configuration. And on the basis of this, you can see here also, here we have seen it's a tetravalence. Here also you see how many valencies are there? 1, 2, 3, 4. 4 are there and 4 is required, and that's why carbon is tetravalence. And tetravalency shows like that, or it is also shown with the help of the dot structure, and this is called what? This is called the electron dot structure of the, this is the valency of the dot structure of the carbon. So, and with the help of carbon, now it has the 4 electrons. So 4 electrons are there. It's very difficult to get 4 electron. It is very difficult to donate 4 electron. Why? Because now just to see, this is the carbon and these are the electrons. These electrons are there exactly very nearer to the carbon, and it's very difficult to lose 4 electron, and it is very difficult to. So just carbon neither donating the electron or not accepting the electron, but it will be share the electron, and by sharing it will prepare the bond and forms the compound. For example, here 4 valencies are there. If this is the carbon, it has the 4 free valency. We can denote like that. These are the 4 free valencies are there. So any compound will come with a 4 electron and it will form the bond. For example, hydrogen comes with the 1 electron here. Another hydrogen comes with a 1 electron. Another hydrogen comes with a 1 electron. And in this way, 4 single bonds are formed. And that's why carbon shows the tetravalency, and it will form not only the single bonded compound, double bonded compound, triple bonded compound, but also it formed the uncountable number of ring compound also. And this tetravalency is shown like this. It has the tetravalency. Just to see, if this is the carbon, if this is the carbon, it has the tetravalency. These are the 4 valencies. So one bond, this is the one bond, this is the another bond, this is the third bond, and this will be the 4th bond. In this way, these are the tetravalency shown by the carbon. Thank you.